Hi guys, this is Bruno Gobato. Welcome to our model learning how to design and how to draw a implant. In this module, we are going to design, to create and to 3D draw a plate clavicle, a locked clavicle plate. Here we have an example in video. So this is a titanium plate, locked plate for clavicle. Here we can see it's shaped, S-shaped just as the clavicle. And here we have two types of screws. We have the locked screw, shown here, and we have the cortical screw. This is one. So we have two different types of screws in this implant. We are going to learn how to draw this implant in order to plan our surgeries. Let's show you some examples. Here we have a clavicle fracture, as you can see here in this model, and we are going to plan a surgery just like that. So we have reduced the fracture right here, as you can see, and we are going to plan the surgery. In order to plan the surgery, in order to create patient-specific guides or everything, even to 3D print your planning, we must have the implant in 3D. So some manufacturers maybe allow us to have their 3D models, but to have freedom to use any manufacturer you want, you should learn how to 3D draw your own implant. And that's what we're going to show you in this video, in this classroom. So here we have an example of a clavicle fracture with two different implant choices. So we have one implant choice right there, and we have a second option right here. So we have draw these 3D implants using the actual implant as reference. So by doing that, we can choose which implant is the best choice, where the screws should be, the locked and the non-locked screws. In this case, we can see that the locked screws are the red ones and the cortical or non-locked screws are the white ones. Okay, that's how we draw. And we are going to teach you how to do that. The first step is to measure the implant. We have here one of our example, okay? We can make this in many ways. We can use a simple ruler to do this, as you can see here. We can use a caliper, an example of how measuring it. And I think we should use a caliper, but the easiest way to do that, and because we have so many implants, is to take a picture of your implant using a scale paper. So that's what we're going to show you right there. So here we have an example of some implants. These are the clavicle locked plate implants, as you can see here, all the available. And I took pictures them using a scale paper just behind, okay? This, for me, is the easiest way to draw. We can use a scale paper, as you can see here. We can use even iPad and iPhone apps that has the scale paper or ruler as reference, okay? So we're going to draw. I suggest you to take pictures exactly from each implant. For some, this is the example we are showing you. We have taken a picture just from above to have to avoid distortions, okay? And the next part is to crop that image to fit exactly the implant. So open the image in any image editor. I'm going to use the preview from Mac, but you can use the Paint or every image editor. Even the PowerPoint can do that. We are going to crop the image exactly in the distal part of the implant, as you can see here. But one of the sizes should fit perfectly, as you can see here. So we can So we can show you here that it's perfect in this side and it's perfectly in this side. So why this is important? Because we must know for sure that distance. The other distance is not that important. So we are going to crop, and now we have that image cropped perfectly. Okay? This is the step number 1. Now we are going to measure this implant. In order to avoid having these tools, doing this by hand when you are with the manufacturer, you can do this at home using some software I'm going to show you right now. We are going now to measure our implant. We're going to use a software called ImageJ. It's a free software, anyone can download it online. It's for Mac and Windows. And then this will allow us to measure some parameters of our implant. In order to avoid measuring everything with a caliper, as you can see here, we can measure it in our computer using a scale paper. This is a very simple software and will help us a lot. Let's open the file. Click here to the ImageJ. It's already open. As you can see here, this is the ImageJ software we are going to use. Okay, we are going to open the image. We have just cropped it. Okay, so here we have the 12 plate, as you can see here, locked screw. And the first step is to set our measure, to set our scale. And what's that? We are going to tell our software that that distance corresponds to a well-known distance. So we are going to choose the line tool, as you can see here, the line tool from the toolbar, and we are going to draw over the scale paper. We know for sure that this is a scale paper, and this big square represents 10 millimeters or 1 centimeter. So that's where we're going to draw a line here. If you are not sure, you can move it. Okay, we have a line over 1 centimeter. And now we're going to press here Analyze, menu, Analyze, Set Scale. So now it opens some menu, and we know the distance in pixels and the non-distance. Well, we're going to use 1 centimeter. Okay, and the unit we can use centimeter or millimeter, doesn't matter. We know that that line we have just drawn is 1 centimeter, so we are going to use the centimeter. Let's click OK, and OK. Let's delete our line and let's check if our measurement is correct. So let's draw again another line over two squares. Okay, that's okay. We're going to click Analyze and then Measure. And here we have the length of 2 centimeters. So here's the angle. The important is this, is exactly 2 centimeters. So we know for sure that this line is exactly 2 centimeters. Now we can take measurements. So we are going to measure this file, this clavicle plate, as you can see right there. Let's click Analyze Measurement, and we know for sure that this plate has 10.6 centimeters of length. This is one of our important measurements. We can also measure the distance between the two screws, to check if we're going to download to create it right. So let's do it. For example, let's create another line. Let's draw from the middle of this cortical screw to the middle of the other locked screw, and let's measurement. analyze, measure, and we know that that distance is 0.7 centimeter, 0.75 centimeter. So we have to replicate it in our draw. So let's take a print screen of this of these measurements, and let's open our CAD software. The next step is to open our CAD software to really design and create our implant. There are many softwares available on the market. For this purpose in video, I'm going to show a software called Rhino, Rhinoceros. I'm using the Mac version for this software. It has Mac and Windows version. The Windows version is more complete. The Mac is not that complete, but it's the software I like to do most of my things. There are other options like Tinkercad, Fusion, 360, and other softwares. Even Blender can do this. We're going to open the Rhino. So let's show here. This is the software I'm using, the version 5.1. Okay. Here what I like about this software is that we have all the views. So we have the top view, have the front view, the right view, and the perspective view. We have all the views together. This helps us a lot planning surgeries. So we are going to design our implant. We're going to make a 3D version of this implant. So the first step is to set our scale. That's very, very important. And that's why all those steps previously we have shown you is very important. So it's important to take our measurements. We know our plate has 10.6 centimeters. Okay, we have just measurement. So, and we know that this image we have cropped, okay, that file has 10.6 centimeters. So this is the big tip for designing implants, is to have the picture cropped correctly and the correct size. So 10.6 is what we measured, okay? So let's open Rhino. We are going to show here the grid options, okay? We are going to select the units we're going to use. We can use millimeters or centimeters. There is no problem. We can use it whatever we want. I'm going to change to millimeters. Yes. Okay. And now we know that every small square is 1 millimeter, so it's just as our scale paper, okay? We know for sure that our implant has 10.6 centimeters or 106 millimeters, okay? So this dimension here from here is 106 millimeters. We're going to use the grid line count as we show here. Grid line count. We're going to put 106. If our implant has 305, we're going to choose 305. So we're going to choose 106 because this is the length of our model. Okay, let's click OK. Now we have a square that has 106 by 106. This is just the length of our implant. We are going now to place the image file in the CAD software because we're going to draw over the image file. That's very important. So we're going to go here to View, as you can see here, View, Background Bitmap, and choose Place. Okay, it will open, and we are going to choose that cropped image. Here, as you can see, we have just cropped. And now we choose where to place that cropped image. I'm going to choose the top view, as we're going to see from top, just like that. This is the view we're going to have. I'm going to place it just in the middle and end that just at the end. Why? Because we know for sure that that image has 106 millimeters, and we know for sure that this square has 106 millimeters. So just place like that and click done. Okay. Now we have our image placed in scale. And now we are going to draw the implant itself. So we're going to choose only the top view, as you can see here. So we have the top view, and we're going to draw lines over the implant. So we're going to choose this control point curve, as you can see here, and start drawing along the implant. So let's click it. We can choose any start point, that doesn't matter, and we are going to point and click around the implant, as you can see here. Okay, takes around, and we're going to point and click. Most implants are more flat. This is a difficult implant. Of course, for planning a surgery, it's not needed to have a perfect design of the implant. What is the most important is the orientation in space of the screws. If you have a small bump over the clavicle implant, that would not be very important. So we do this more like approximately we could, but it's okay. So we have here a line over the implant, as you can see here. Now we are going to create a three-dimension model of this implant. So we now have the implant like that, and we are going to create depth in this. We know that this implant has 0.4 millimeters in depth. That's important. So let's go to our view. As we are looking from here, from top, and here we are looking from front and from right. Okay. So let's select our line. Select solid, as you can see over here. Extrude, planar curve, straight. Okay. Let's go back here, and here we choose where to extrude. Here we can do this manually, but we can enter here it's 4 millimeters. Let's click OK, and now we have our implant, as you can see right there, our clavicle implant with 4 millimeter depth, just perfect. Now we just need to add the screws. Okay. The next step is to draw the screws. So we're going to select the line, the curve. We don't need anymore, so we're going to delete. We already have the model, it's a solid. And we're going to design the screws over this model. The screws are simple cylinders. We're going to draw simple cylinders over this model. This is a solid model, as you can see, so we can't see very good through it. So we're going to change its property. Let's double click in Mac or right click over the top and click Object Material, as you can see here, Object Material. And here we have some choices of materials. These materials I have already saved here. You probably have no material right there. We're going to create another material. Let's click on the plus sign. Okay, let's name it to transparent. So we know this is a transparent material. And on transparency, as we can see here, transparency, we're going to choose the amount of transparency we want. Let's put something like 85, 90%. Okay, and let's just draw this sphere over the implant we want. Okay, and now we can see here this is almost transparent. This is important for our next step. So we have here our implant. If we select, we can see it, and we're going to draw the cylinders, the screws over the image. So we can draw using the same color, but we can choose other colors. In this right side here we have other colors. If you don't have, you just have to assign a color for you. So we are going to choose the red color for the red cylinder. So we're going to create our solids. Let's click here on the solid menu, solid, and create cylinder. Okay, so solid cylinder, and this will draw a cylinder. We're going to choose the top view, okay, and we're going to first use the cortical screws. Okay, so we have here 1 cortical screw, 2 cortical screw, 3 and 4 cortical screws. We're going to draw it over the exact center of the hole. Just click, I have just clicked, and now I can move the diameter wherever I want. Okay, so we can choose by hand the diameter using the image, or we can choose it just clicking here. So we know our drill will be 3.2. We could choose a 3.2 diameter. We could choose a 2.5 diameter for this drill. In this case, this is a small fragment. So in this case, as our drill will be 2.5, I suggest 2.8 to have some tolerance. So let's choose 2.8 in diameter. And here we have our diameter. We use the front view to put the screw just like that. As you can see here, we have the implant and the screw. Okay? What is a suggestion? In order to see from above and from behind, I don't do like that. This is how the plate is, okay? The plate is like that, and the screw will be above. But for me, it's more important to view the screw from all the views. So what I do, I select the cylinder and I put this cylinder in the middle of the plate, as you can see here now in the perspective view. So we have a screw from above and from the top of the implant. And now this is, we can check if it's in correct position. If we are okay with its position, we can draw this again over the cortical screws, or we can just copy and paste. So we can select the implant, we can select edit, copy, okay, and edit, paste. And now we just need to move it, as you can see here, to the location to best fit the hole where we want. So we're going to do this, copy and paste again to fulfill the other cortical screws, just like that. Let's copy and paste again, just as we want. Okay, we have here we have some tips. If we want to do a compression, we can move these 2 screws a little more distally, as you can see here, a little more distally, and we will have more compression when we tighten the screws. Okay, and now we already have our implant with 4 cortical screws, as you can see here. We are going to draw the locket screws the same way. So let's just change the color. I'm going to change for blue. So in this case, the blue will be the locket screw. The same thing, select solid, cylinder, choose the center of the image, and we can now choose the diameter. Diameter is 2.8. As this is a locked screw, generally the drill is a little bit wider, so I'm going to suggest we use the 3.0 millimeter diameter, and we can choose the same size. Let's do the same thing. It's good to have the screws in the middle and from above and behind the implant. So we have here one screw. Let's copy and paste and place it over the other holes. Oh, it's not okay. If it's not okay, we can check it. We can move it for a more convenient position. Okay? We are done. We have now our implant already drawn, as we can see here. Let's change the color. In order to see it again, let's click Object Material, just as we did for the first time, and just let's change the color. I'm going to put a yellow over the plate, so we are going to, it will be easier to understand. So here we have the implant. We can now draw over the implant to make sure we are okay with that. So we can choose here the text object if we want, and let's click right 12 holes. For example, we can just click over the top of the implant. If we want to be it smaller, just do this smaller, and now we have our implant done. Okay, right 12 holes. We can now select everything select, edit, and group, as you can see here in the edit menu. And now it's a group of objects we can use to plan our surgery. Now that we have our plate done, we can check some measurements. So remember, we have just taken some measurements in the image.j file. So here we have a distance of 7.5 millimeters from the cortical screw to the locket screw. We can now go into check if this is okay. So let's check. Let's click in Analyze, Distance. We're going to choose the middle of this screw. Remember, we have put this screw a little bit distally, so I'm going to compensate it, putting a little bit more proximal, and analyze if the distance is correct. And as you can see right here behind here, we have the distance of 7.4. We have measured 7.5. It's very accurate, our measurement. So here we have our implant done. We can choose this implant and import it in any planning we have. Just let's select the implant. As you can see here, we can choose copy. We can save it as any file, but let's open that first file. I'm going to delete here, delete these other implants here. Here we have the clavicle we have already reduced. Just let's edit, paste our object, and this is the implant we have just drawn. As you can see here, it has no colors, because in this file I have chosen different colors. As you can see here, there are different colors. So, but it's done. We can now use this for planning our surgery. We can check the correct position of the implant wherever we want, as you can see here, just like that. For example, let's put it a little bit like that. And this is why I choose having the screws from above and behind, not just as a plate. And this is important when we design patient-specific guides. So here we can see all the screws, okay, and how it will be in our clavicle. And what is important, and what I think it's most important when we have designed our own implants, because we can, for example, know exactly where the screws will be only on the lateral or on the medial side of the fracture. Just like that. For example, let's select our implant. I'm going to select Edit, Group, and Ungroup. Okay? So now the plate is not important anymore. The important part is where our screws will be. Okay? So in the surgery, we know that in the lateral fragment, as we can see here, this screw, the fourth screw, will be just like that. So for example, for planning a surgery, you can delete this and have in your OR room just this image, and you make sure that all the screws are in correct position. And if during surgery we open the patient and you drill this in the exact position, we are sure that all the plate will be in exact position. We are back to our implant. Let's do another thing. Let's select the implant again. Let's ungroup it, edit, group, ungroup. And now let's create a plate, just like that. It's very simple. We're going to select the implant, so only the plate, as you're seeing here. We're going to select solid and difference, just like that, okay? Select difference. And now we're going to select screw by screw, here, screws, all the screws. And hit enter or done. And here we have our plate with the screws. If you have a 3D printer like I do, like my printer's right here, we can 3D print and make sure that that implant is in correct position as the right implant, as the original implant. Okay? Another important feature, I'm going to go back, is some screws has different positions. Some locket screws has different positions. In this case, and in this implant exactly, all the locket screws are in the same position. So all the locket screws, as you can see here, they are 90 degrees from the plate. Okay? So for this is correct. But if we had a screw with a different angle of position, for example, if we have a screw with 30 degrees of inclination, for example, like that, we could just change it. It's very easy. We have to measure it. We can take pictures and measure the inclination. Okay, it's very easy to measure the inclination in Image J, just as I showed you. But let's assume that we have a 30-degree inclination of this screw. So we just select that screw, for example, right here, and we click here on the angle tool, as you can see here, and select 30. And now we have a 30-degree inclination, and we can change it, the inclination, wherever we want. So let's do this again. If the screw is tilted that way, just click minus 30, and we would have a 30-degree inclination. If the inclination is in the other way, so if the inclination is not medial or lateral, if the inclination is anterior and posterior, the same way. We just click in this view, it will be just like that view here, and we can change the inclination. Let's change for 15 degrees. For example, if we would have a 15-degree inclination anterior posterior, just click and we have here a inclination of 15 degrees. This is how we work with inclination of locked screws. When we have a plate that has many screws, this is important, but sometimes I don't opt to draw all the inclination screws. So for sometimes I just draw where they should be as a 90 degree, and I know they will have some inclination, so I know that maybe it will be a little different from what I plan, but for me what is important is the exact position in space. Now we have this file done. We just select and save it, or we can even export as any file. We can export as an STL file in 3D print or any other files where we can choose. This file will be available for you to download freely. You can look, you can use it, you can open in Rhino, and you can change if you want. Okay, thank you.